that Kevlar is still synonymous with body armor when it was invented in 1965. Hi, I'm Abby, this is Ian, Neil, Bailey, and Keith, and we are Triple Point Materials. Body armor is so uncomfortable that 1/3 of police officers choose not to wear it, making them 14 times more likely to be killed on the job. This is a materials problem, and we are a team of material scientists eager to solve it, and we've come up with a solution that we're excited to share. We've created an additive that, when incorporated into ballistic plastics, strengthens them, thus making them lighter weight and more durable. Additionally, we can incorporate our material into commercial plastics for enhanced performance. Through over 20 interviews, we found this laundry list of problems, and we decided to focus on 2, backface deformation and delamination. This is a sample plate that I shot to show the harmful effects of backface deformation, which is when an incoming bullet hits the plate and actually buckles into the person wearing it up to 2 inches, causing severe injuries. Other ballistic materials, like Kevlar and specialty polyethylene, when incorporated into a vest, are typically 20 to 30 layers thick. However, when these are shot, the layers can peel apart, called delamination, which is also a serious problem because if these layers come apart completely, the entire vest is ruined.
We created 2 body armor panels to be able to test our material in a high-strength application. They were made by layering fabric and epoxy while putting our material into the epoxy of the second panel here. We tested each panel with a .22 caliber bullet as well as a 9mm bullet. The control panel, the first one here, without our material in it, failed when shot with a 9mm, while the second panel with our material stayed together and stopped the bullet. As you can see, the control panel without our material delaminated into 3 different sections as well as experienced backface deformation in the Boston region, while the panel with our material did not experience any backface deformation and only minimal delamination.
The question is, how did we do it? We created a nanofiber additive that increases the strength of materials when we put it in. Nanomaterials are known to increase the strength of plastics, but conventionally are very hard to make and are nearly impossible to scale. Body armor manufacturers have been promised nanotechnology over and over, but have nothing to show for it until now. We created a nanofiber additive that we can produce in large quantities. The phrase scalable nanotechnology has traditionally been an oxymoron in industry, but is becoming a reality through Triple Point Materials. Our advantage comes from how our material interacts with other materials. Just small additions can increase the strength by over 1.5 times and double the stiffness, leading to reductions in both backface deformation and delamination. We are bringing body armor performance into the 21st century, but this is just the tip of the iceberg when it comes to the uses of our material.
The body armor industry produces 350 tons of material annually, but the global plastics industry produces hundreds of millions of tons. This just goes to show how massive the potential market is, and body armor, it's just the beginning for us. Every one of you has had something plastic break on you. The global plastics industry is a $500 billion market. Depending on the application, we can provide customers with cost reduction, product enhancement, as well as the ability to actually replace existing materials like metals and ceramics with plastics. Crap, I am completely blanking. I am sorry. This allows us to enter a whole new realm of markets like packaging, automotive, consumer goods, even 3D printing, and so many more. So how are we going to reach these markets? Before hiring an experienced salesperson, we are going to conduct our B2B technical sales through cold calls and networking, which would include going to trade shows as well as conferences like Plastech East, which is happening in June.
Patent protection is going to be a key part of driving our business because our platform technology is going to generate a whole portfolio of intellectual property. We've spoken with several patent attorneys and we're beginning the process of writing our first patent. Our competition consists of 2 companies that claim to manufacture materials similar to ours at scale, but they have fewer than 5 employees each, and they've been in business for over 10 years. Their patents don't really cover the benefits that we've discovered, and Their technologies just don't scale like ours can. Our primary risk in scaling up is going to be ensuring that best practices are used with our raw nanomaterials until they are safely composited into a plastic. Moving forward, we're planning to have a kilogram scale pilot reactor built by the end of the summer, and from there, by the end of the year, we're going to be landing our first sales and seeking Series A funding. To get there, we're seeking $50,000 to build that pilot reactor and fund further market research to solidify our go-to-market plan. We'd like to extend a warm thank you to our professors Marshall, Beryl, and Seth. They've made the EEP possible, and it's been a great opportunity. We want to extend a special thanks to Kara Segerstrom, our Plexus mentor. She's been invaluable throughout this process and given us a lot of time. And finally, we want to be especially grateful to Dr. Jerry Cuomo, who has provided us lab space and invaluable guidance. We welcome questions now or afterwards